Hi, my name is Christian Meisel. Let me introduce you to the Thomson Reuters Tech History REST API. This presentation will be useful to you if you are new to this product, or if you are in the process of migrating from version 1 and its old SOAP API to version 2 and its new REST API. After a quick overview of tech history, we shall look at a few use cases and then jump into the TRTH REST API with a demo of some of its capabilities. We will then wrap up with additional useful resources that will help you learn this API. Thomson Reuters Tech History, or TRTH for short, is a hosted delivery platform for historical cross-asset financial data. Data can be extracted using its graphical user interface, using HTTPS. But everything can also be done using only the REST API. TRTH is a mature but constantly evolving product with regular updates to adapt to evolving content and delivery requirements in the marketplace. Today, you need deep historical data to analyze the markets and gain profitable insights. The quality and breadth of the information empowers you to find new opportunities ahead of your competitors. Thomson Reuters Tech History addresses these needs. To content coverage, TRTH offers a variety of high-quality, cross-asset, non-streaming, pricing and reference data, with worldwide coverage, all from a single source. Captured from Thomson Reuters real-time data feeds, TRTH offers global tick data since 1996 across all asset classes, covering both over-the-counter and exchange-traded instruments from more than 500 exchanges, and third-party contributor data, the majority available 2 hours after markets close. Through custom delivery, in example bespoke requests, you can retrieve pricing data. That is time series, level 1 data, trades and quotes, auctions, corrections, market statistics, order imbalance. Market depth, that is level 2 data, market by price, market by order, and also end-of-day prices and intraday bars. There's also reference and other data, like corporate actions, cross-reference, in other words security identifiers, symbology changes, terms and conditions, and historical chain constituents. Venue by day data are pre-packaged data sets covering all the data for data providers, time series, market by price, and you have 30 days of history which are available. Note that data sets are subject to permissioning, so depending on your subscription you might not have access to all the data. As an example, venue by day data and some third-party data is subject to particular permissioning. In case of doubt, check the content of your subscription with your account manager. Here are some use cases for tick history financial data. For all of these, data coverage must be as complete as possible across all asset types. Data must be of good quality and available in a timely fashion. It must also be easy to access and retrieve at any time. Meeting all these requirements can be challenging, especially when working with multiple data sources. But for historical data, Tech History meets all these expectations through an easy-to-use RESTful API. So, what is TRTH? It is a hosted internet service. You can access it from anywhere, and there's no need to install anything. TRTH version 2 data is delivered by the same servers as those that deliver DSS, in other words Datascope Select, which is a slightly different product offering. The access requires a user account, a user and a password. Data like venue by day and API calls, in other words those of TRTH or DSS, well, for all of those access is controlled through account permissioning. Note that there are a few documentation overlaps between both products, but if you attempt to run an API call you are not entitled to, a very clear error message will be returned. The data consumer can be the browser-based graphical user interface, which allows requesting and retrieving data. And then there's the API, which can not only replicate what you can do in the graphical user interface, but it also has additional capabilities. As a TRTH customer, you can use either the graphical user interface or the API, or combine both to optimize your workflow. Data can be extracted using either of two basic mechanisms. The first is scheduled extractions, which occur at a predefined moment in time, once off or recurring. These can be created using the graphical user interface or the API. This type of extraction was already available in the previous version of the product. Then there are on-demand extractions, which occur immediately. These are high-level simplified calls, which can only be created using the API. This is something new that was not available before, so if you're migrating from the previous version, you might want to look at this closer, as it might simplify your workflow. Venue-by-day extractions are a different use case. They are automatically generated daily after market close and can be downloaded using the graphical user interface or the API. This is also a new feature. The choice of mechanism depends on the workflow you want to create. These mechanisms are not mutually exclusive. For instance, you can use venue-by-day extractions for daily entire venues data, scheduled extractions for specific data you require on a regular basis, and on-demand extractions for ad hoc queries. Scheduled extractions are typically used for data requests that are performed regularly. An example could be daily corporate actions data requests, or end-of-day data. A scheduled extraction requires 5 steps. First, we create and populate an instrument list, which is saved on the Data Scope Select server. The list can be created, populated, and modified manually using the graphical user interface. It is also possible to import a CSV file directly using the graphical user interface. The list can also be created, populated, and modified using the API. A list is persisted on the server until you decide to delete it. Instruments are validated before being added to a list. In this context, the instrument historical search tool allows you to find instruments, which can be very helpful. Then, we define a reports template, which is also saved on the Data Scope Select server. Reports templates are created by choosing one from a list of available default templates, and then customizing it by selecting which data fields should be part of the returned results. Again, this can be done using either the graphical user interface or the API. Here is the list of currently available reports templates for tick history customers. They correspond to the data landscape we saw at the beginning of this presentation. New releases of TRTH may include new report templates. The list of available fields is specific to each report template. It can be displayed in the graphical user interface or queried through the API. You can include as many of the available fields you want in the template, but for obvious performance reasons, it is best to select only those you require. When analyzing the list of fields for a specific report template, each data field has a description, which helps in choosing the right one. In case of doubt, the best method is to select all potential candidate fields during the prototyping phase. Then, check the return results to determine which fields return the data you require, and finalize the field list. This prototyping can easily be done in a free tool like Postman without any coding. This exercise needs only to be done once, as field lists will usually not require changes. After creating the instrument list and report template, the next step is defining an extraction schedule, which is saved on the DSS server. It can be executed one single time or run on a recurring basis. A schedule must refer to an existing instrument list and report template. Combinations are of course possible. Several schedules can be defined for the same instrument list and the same or different reports template. We then check the status of the extraction by interrogating the server. Once it has completed, we can retrieve results from the DSS server. All these operations can be done using the graphical user interface or the API. Some combinations are also possible, like importing an instrument list from a CSV file manually and then referring to it in a schedule created using the API. This allows you to accommodate your workflow in an easy way. Here is the same workflow illustrated by a diagram. The first line is the instrument list creation. Note that when instruments are added to a list, a validation mechanism is used. Invalid instruments are automatically rejected. The second line illustrates the creation of a customized report template by choosing a default one and selecting the data fields. The third line shows the schedule creation and waiting for the extraction request to be triggered. The last line is polling for the extraction status and then retrieving the data. On-demand queries are high-level calls made through the API. This is a new feature of this version. They do not have their equivalent in the graphical user interface. We obviously need an instrument list, but this is managed on the client. It is not saved on the server. Instruments can be searched using API calls, so automated workflows can integrate such capabilities. Instead of defining a reports template, the request is made directly, but the API call itself specifies a data type, which in fact refers to a default report template. In other words, here we are covering the previous steps 2 and 3 in one single API call. Even if the mechanism is different, we are referring to the same templates we saw previously. So the request contains the instrument list as a parameter, implicitly refers to a default template by the fact that you chose a particular API call, and it includes a list of data fields again as a parameter, and those data fields are specific to the template. If required, the list of available data fields can be queried using the API, thus facilitating automated workflows. But, as stated before, for performance it is best to optimize the field lists during the prototyping phase. Once the query has been submitted, we check its status by polling the DSS server. Once it has completed, we can retrieve results from the DSS server. Note that nothing is persisted on the server, neither the instrument list nor the custom report template. Venue-by-day queries allow listing all user packages, all files for a package, and retrieving individual files. There are several files per day: tick, depth, raw, corporate actions, reference data, and instruments. The instrument list is the entire universe of instruments for Venue. The report templates are predefined and cannot be tuned. And the data extraction is triggered by data availability after market close. So, once files are available, all we need to do is retrieve them from the DSS server. Now let us talk about the API. Two versions of the API currently coexist: the older SOAP version and the newer REST version. A .NET software development kit is available if you want to program in C#, but as it is a REST API, any language can be used. The API is rich and delivers many capabilities. Some mimic what you can do in the graphical user interface. Other capabilities, like on-demand extractions, in other words, on-the-fly requests, are only available in the API. The API is flexible. You can schedule extractions tailored to your needs for anything from one instrument to large datasets, selecting the data fields you are interested in, etc. We recommend you use the REST API. It follows industry standards best practices, is simpler to use, has better performance, and more capabilities. If you have not yet started development, you must go for the REST API. If you have already developed something using SOAP, then you need to migrate it to REST. Here are some of the reasons why. The SOAP API will be obsolete at the end of 2017. As of 2018, only the REST API will be available. SOAP only supports synchronous calls. It might therefore suffer from long calls that are just hanging, waiting for results. Long quiescent TCP channels can be disrupted by network calls that limit their duration. The REST API supports asynchronous calls, which allows for a client-controlled disconnect between initiation of an extraction and the collection of the results. Data coverage is greater thanks to Electron data instead of the IDN data. Only REST offers API access to existing lists, report templates, schedules, and file-based results. This gives you the option of creating them manually and then using them programmatically, which can be quite practical if they hardly change in time. With REST, there are no more limits on the size of datasets, allowing you to retrieve them as a single file. Only REST offers streaming of large results through the API. The REST API is richer, has a .NET SDK, more API calls, and gives access to more data like commodities, energy, and corporate actions. Now let us see this in action. Let me first take you to the developer portal. And let's go to the tick history section and select the REST API. Now, in there's a quick start, which explains the usage of a REST API C# example application. And this is what I'm going to show you now. This quick start explains how to install it and how to use it. So let's see this in action. After following the installation process, which is described in the quick start, you can run this program in several ways. If you have Visual Studio, if you like, you can open the solution and run it from there. If you don't have Visual Studio, you can also go to the bin directory and run the executable directly. As you can see, you need to log in to this, so again, you need your account. The purpose of this application is to demonstrate most of the API calls. It applies both to Datascope Select and to tick history. So, in other words, depending on your permissioning, well, some calls will work and some will return errors. So, for instance, if we want to run tick history commands, we have a set of them here. If you have venue by day, then you can also go here and run these. The purpose of this is not only to show you how these calls work, but also to show you the code which is behind them. And this in two ways: in C# code, which you can copy out of here and directly into your prototype to start playing with the API, and also as HTTP requests and HTTP responses, which has the advantage of being usable for any other programming language. So you can copy these into Postman, for instance, test them in there, and then when you're satisfied, well, recreate them in any programming language you want, for instance, Java. Let's have a quick look at a few simple functions and how this actually runs. First thing, when we authenticate to the system, we need to request an authentication token on the basis of our username and of our password. If I come here and click on C# full here, I see the C# code to request an authentication token. It is using the SDK, which also makes it quite simple. I can run this code, and now I see it has run. There was only one single step in this code here. I can see now in HTTP the request and the response. Now let's do a slightly more complex one, and let's get some data. How about some intraday bars? So let me run this again. Notice, by the way, that you can truncate the results to limit the amount of data which is returned. That's just for display purposes. You can untick this box to see all the results. Let's just see the C# code while we're at it. So here we see the entire code, which shows us how we request an extraction, define all the parameters, and then receive the results. The extraction has completed. We see that this piece of software has 4 different steps. One which gives us the list of fields, one which extracts the data. Well, actually it has 2 steps. The first one is to request the data, and the second one is to check its status. And then the third one here is to get the actual data. When you select one of these, you see the relevant code is highlighted in yellow, and if you click on C# snippet, you will see only that code. So that allows you to study the code in detail. Again, here this is C# code, but when you go to the HTTP section, well, you can see the request and the response, in this case with the actual data, and obviously the prior steps as well. This is extremely useful for you to learn how the API works and what type of data to expect in return. And obviously, these HTTP requests, if you create the same request, they should work and you should be able to get data. Let's move on to another way of experimenting with this API, which is using a simple third-party application to send HTTP requests, which could come out of here, or be written manually or taken from some tutorials. What I am about to show you now is also explained in the tutorials. So if you go here and then you scroll down, and you will find these REST API tutorials. The first one here explains how to install a product which is called Postman, and this one allows you to run some queries. And that is exactly what we're going to do. And once you have that, then you can go through all these tutorials here, which show you simple requests and response scenarios with the HTTP requests and the HTTP responses, which you could copy out of the application we just saw, out of the tutorials, or also in the downloads section. You will find that there is a collection for Postman. You can download that and install that inside Postman, and in that case you will have all the calls directly there for you. So let's see that in action. This is Postman, inside which I've installed the downloadable collection, which is here, and also the environment which comes with it, which contains a whole set of variables which help us work with this collection. Let us start by authenticating to the server. This is the subject of tutorial 1, which is on the portal. Here you can see some instructions on how to use every single one of these calls here, so each one has its own instructions. To authorize to the server, we first need to request an authentication token. That is done using this endpoint. We have two headers defined in our HTTP request. One is that we prefer asynchronous responses. Remember I mentioned that the REST API has the possibility to use asynchronous responses. Well, this is how we actually request them, and this is what we're going to do for all our calls. The second header is to specify that the content is JSON. Here is the body of our request. This is a post request, as you see here. This is our credentials, which contains our username and our password. Both of these come from the environment variables which are defined here. Before you run this on your own machine, you'll have to set your username and password inside the environment variables. Let us run this. Here we see the response. The HTTP response status is 200, which is okay, so everything went well. In the body of our response, we see it is formatted in JSON, and inside here we find our authentication token. So let's copy this and throw it in here. This is now our authorization token, which will be used in the subsequent requests. Here you see there is a whole set of calls to create instrument lists, reports, templates, schedules, and retrieve the data and delete all those various things we created afterwards. That is very similar to what we saw previously. So let us move on to the second way of calling data, which is on demand. Let us start by this call here, which is to list all the available fields for tick data. Here we see the endpoint. So this is an extraction. We are getting the valid content field types, and this is for a particular type of reports template, which is tick history, time and sales. Let us run this. I forgot to show you something, the headers. Inside the headers we have a third header here, which is now the authorization, which contains the word token and then the code we just copied from the previous call. So this is the third header we use in all our requests. Here is the response with the list of fields for a time and sales request. Each field has a code, a name, which is what we need to use in the next calls, a description, a format type, and a field group. So notice this is a field for auctions, for instance. And if I scroll down, I find fields for corrections, for quotes, and still further down for trades. As you can see, there are very many fields to choose from. And this corresponds to the list of fields, which you can also see when you open up a reports template inside the graphical user interface, like we did at the beginning of this presentation. Once you have your selection of fields, you can extract data. Here is a request. It is a post request. Here is the extraction endpoint. Notice it doesn't mention the type of data. That is in the body of the request. The body of the extraction requests contains the data type. The data type is a tick history time and sales extraction request. If we were running a different request for a different data type, well, this part here would change. Then we have our list of content field names. Here we see we just selected 3, price, volume, and exchange time. These were selected from the lists we had in the previous call. One of the parameters, as we mentioned at the beginning of this presentation, was that you need to specify the field names. That's one of the parameters. And then the other parameter is the identifier list, the list of instruments. Here we just specified one, which is a RIC. As you can see, this is an identifier type. We could be using other identifier types apart from RIC, for instance, ISIN, QZIP, etc. More than 30 of them are supported by the system. Finally, there's another parameter, which is the conditions for this call, and that specifies things like the time zone for the message timestamps. Do we want to apply corrections and cancellations? In this case, this applies because this is ticket data. The range we want for our query, so this is data from the 29th of September 2016 from midnight till noon, and we want to include the source RIC, in other words the identifier, in the results. Well, if you have more than one instrument you had better, otherwise you can't separate them, so usually we set this to true. This is the body of our request. Let us run this. The request will time out after 30 seconds. Either you have the data in that time frame, but that is very, very rare. So most of the time what you'll get is an HTTP status of 202 accepted. That means that the request has been accepted by the server. It is being processed, but currently the data is not yet available. Now, if I look in the headers of this response, I will find the location URL. This I will copy and put inside here. Because this is going to be used by my next call, which is a get on this location URL. That is to check the status of our request. Let us send this. This time we receive the status 200 OK. Inside the results we find a job ID. Let us copy it in here. We also find some extraction notes here, text, and this contains this little sentence which I'm searching for: processing completed successfully. That means all went well. We also have some other details, obviously. When does this all happen? How many instruments were there? How much did this impact my quota of instruments I can request? All kinds of stuff like that. Now that we have this job ID, we can request the data. So this is again a get, which is sent to extraction results, and using as parameter the job ID directly inside the endpoint. We submit the request. The HTTP response status is 200 OK, so everything went well, and here's our data. Great. This was just one example. There are more here in the series here, so you have examples for market depth, for intraday bars, for end of day, for raw data, etc. Let us now look at a different request, which is a historical search. A historical search can be used for several things. Well, to search for an instrument, to find out if the name is correct, but you can also use it for cross-referencing. And that is what we're going to do here. We are searching for an identifier here, which is an ISIN. We're searching for a certain date here, and we want to know what are the corresponding RICs for this identifier. Let us submit our query. Here is our response, and the response tells us that there are a whole list of RICs for this ISIN. We have IBM, IBM.C, etc., etc., etc. So we've got the entire list of RICs which correspond to that ISIN for that particular date. Now, maybe you only wanted the primary RIC. Well, that's easy to get as well. We can do a request on terms and conditions. The request body is here. So in this case, I'm actually querying several instruments in one go. And for all these instruments, a QZIP, a RIC, an ISIN, and a CDAL, I am asking for all these fields to cross-reference this. Let us run the request. Here's the result. This time, for every one I requested, there is only one result, which is the primary RIC. As you can see here, there are other searches which are available inside this collection and the tutorials. Feel free to play with them and discover what they can do. Now let us move on to Java. Under the Downloads tab, you can find a package of Java code samples. You can download these and run them. Let us go back to the tutorials. Under tutorials, you will find a Programming Without SDK tutorial. This one is very useful in the context not only of Java, but also of other languages. It explains how you can move from the Postman requests, which we've seen, pure HTTP, and implement those in a different language, for instance Java, but that's just an example, and manage the responses. I shall run some of these samples using Eclipse. Here is, for instance, a sample to do a scheduled request for intraday bars. Let us first look at the workflow of this sample. Here are the steps we will see in this code sample, which illustrates setting up a scheduled extraction. They mimic what can be done in the graphical user interface. After authenticating to the server, we will create an instrument list, a report template, and a schedule. All of these will be persisted on the server. Then we will check the schedule status and wait for the extraction to complete. Once that is done, we will retrieve the results. Finally, as this is a demo and we do not want to reuse these components, we will delete the instrument list, report template, and schedule. Now let us look at the code. Here is the main program, which shows all the calls to the methods we have defined for this. It is demo code, so some of these are not really useful in this workflow, but just there to demonstrate various possibilities. Here is the method to get the session token for the authorization. You will recognize the URL we use to request that token. You also see here that we define the header and the body of our request, which contains the credentials, username, and password. Once that is done, we can submit our request and then retrieve the token from the value inside the JSON response. So this is just the Java code to do exactly what we did in Postman, as you saw previously. Let us move on further. Here's where we create an instrument list. So we see this is similar in philosophy, defining an extraction endpoint, headers, this time with the authorization token as well, and then defining the body of the request, submitting it, and seeing what comes out of it. After creating an instrument list, we're going to add instruments to the list, which is done in this method here. So here we're adding several instruments of various types, including one which is pure junk just for testing purposes. Here is where we create our report template. So you recognize the definition of the report template, again the headers, and then the body, which defines the report template with its content fields here, and the conditions. Here we see how the schedule is defined, with the various parameters that define it: our time zone, the name of the schedule, its recurrence, so this is an immediate schedule, so it will happen right now, and that will allow us to extract the data right away in this demo. And we see also that it is referring to our list ID and our reports template ID. Now we need to check when the extraction is complete, and that is done using the report schedule ID, which was returned by the previous call. And then we need to poll for the status, and as long as it is 2 or 4, that means we need to wait. So we will continue polling until we get a status code of 200, in which case we have a response. So then we can start treating that, and the first thing we need to do is extract the report extraction ID, which we're getting here from the response, and we're going to use that to retrieve the results. Using that report extraction ID, we can go and find the names of the files and some of their details as well. So we get a list of generated files. Here we treat the response of that query, and we are going to display some of the parameters of those files. In other words, the file ID, the file type, when was it extracted, what's the size of the file, all those things. And for each one of those files, we are also going to extract the contents. And here we have two methods, one which will just save it to disk, and another one which will display the contents to screen. To save it to file, we are going to refer to the ID of that particular file in a new request again. And this request will use a data stream here to receive the data and then copy it directly to file. If we want to display it on screen, it will be very similar. We are again using a stream reader here, but this time we're doing something with the content, which is putting it on screen. Let us now run this to see what it looks like. I have received my authorization token. I've sent out my request to create an instrument list. I'm displaying the response here to see what's happening. This is just for debugging. I've decided to retrieve the instrument list ID using its name, so that's also something you can do. For instance, if you've created a list manually and you just want to retrieve it by name to get the ID and then work with it through the API, that's something you can do. Now we are adding some instruments to the list, and there's some validation which is happening in the background. So the results are displayed here. Now let us continue and create the reports template. And that's just been done. Now, again, same thing as previously, we can retrieve a reports template by name and get its ID in case of need. Now we are creating the schedule. And now we check if the extraction is complete. So now we might need to wait for a time, which depends obviously on the amount of data and the server load. So we have this polling loop, which is checking the status every 10 seconds. 10 seconds is a bit quick. In most cases, we recommend using 30 seconds or more as polling time. But here, as it's a demo, I wanted you to see something lively on the screen so that you see that something is actually happening. There we are. The results have been received now, so the extraction has completed. We have extracted our report extraction ID here, and we're going to use that to see the list of files. Let's go back a bit. Here is our first extracted file, so here are the details on that file. File type is full, that is the data file itself. Here we see the name of the file. And here are the contents, so these are our intraday bars. Here is the second file. This is a file type note, so this is a notes file, and the contents is the extraction notes, which we can see here. And we see the processing completed successfully, so we're happy. Now we're deleting everything we created on the server to leave it nice and clean, because we don't need these anymore in this demo. Now, how can you move forward? As we have seen, the developer portal hosts many resources, and these are located under the Thomson Reuters Tick History API section. After reading the API overview, we recommend you begin by going through the quick start. This gives you the example application we saw that runs and queries the servers and illustrates most of the API calls. It shows you the underlying C# code as well as the HTTP requests and responses, and is therefore very useful whatever language you plan to use. After that, you can go through the tutorials. Start with the introduction and the programming without SDK tutorial. As previously stated, it explains how to progress from an HTTP request to an actual program. It also delivers some best practices and tips to make it easy for you to understand the API calls, including all their parameters, and also contains a work process suggestion that might help you gain time and debug more efficiently. It also contains a troubleshooting FAQ. Once that is done, you are ready to move on, either to the .NET tutorials if you plan to program in C# with the .NET SDK, or to the pure HTTP REST API tutorial set, if you will not use the .NET SDK. The most typical use cases are covered by these tutorials, and it should be easy, once you have understood the tutorials, to move on to your own use cases. The download section includes a wealth of sample code in several programming languages, including all those for the tutorials, the Postman collection, the C# tutorials, and the Java examples. The documentation section includes some very useful guides. Back on the product server, inside the graphical user interface, you also find help pages. And there's also a browsable API reference tree. If you have questions or run into issues, you can go into the portal forum. Select the proper area for tick history. Here you can search prior queries, or you can post new ones. This forum is monitored by our developers in all regions of the globe, so you will usually get a fairly quick response. Thank you for following this presentation. We hope you found this instructive.